opportunity to introduce Dr. Vaibhav Singhal, Associate Professor at IIT Patna. He is a well-recognized academician and researcher in the field of masonry structures. Dr. Singhal is an expert member of the BIS panel for masonry chapter of National Building Code and is also actively involved in the revision of IS 1905, that is Code of Practice for Structural Use of Unreinforced Masonry. And now we are privileged to have him deliver today's lecture on part 6 section for masonry of NBC 2016. And now I hand over to Dr. Vaibhav Singhal for his lecture. Thank you,
Okay,
sir.
thank you. Thank you, Abhishek ji. Thank you, BIS, and a very good afternoon to all the participants. So most of the participants are engineering students.
Yes,
Yes.
sir.
Okay. So today we will be covering about the structural design of masonry as per NBC. So NBC 2016 version. So this, which is a section part 6. So it covers provide an overall idea about various aspects of the masonry design, starting from a new construction, how one can do a strengthening of a old construction from earthquake point of view, and also covering some of the new construction technology which is coming up in India, like reinforced concrete, reinforced masonry, and also the confined masonry. So I will try to give you a brief about all these various clauses what NBC uh, part 6 covers about the masonry design. Now, being engineer, my students also used to ask that, sir, why you are teaching us masonry? Now we are using mostly the concrete, reinforced concrete, precast panels, pre-stressed concrete. Why we are looking out the masonry and why BIS is also troubling you to learn masonry code? Okay. So the reason is we have to first of all look back our history, and we know that our India is divided into various seismic zones. This is 2016, which where we have 4 zones starting from 2 to 5, and now we have another zone adding more severity. We know better about the earthquakes, their severity, their occurrence, and that is how the seismic zoning maps are keep on changing. So just have a quick glimpse. If you remember in 1897, of course, you have not heard about this, but if you see and read in some of the books, which is one of the great earthquake, and it changed kind of earthquake engineering around the world and also in India. So this earthquake was felt somewhere at this location in Assam, and the shaking or the intensity was even felt in Gujarat. And there were numerous examples. At that time, masonry was the most popular construction method, and masonry has performed quite poorly. You can see the photographs of before construction, after construction. So poor performance of masonry everywhere. Even in the earthquake in 1934, after about 40 years, the masonry has performed similarly, kind of a very poorly in most of the earthquakes. Around the world also, in US, California, in Japan, at many places, you will see similar kind of pictures that building will not perform well. So as the previous speaker was talking about being an engineer, your role is to ensure the safety. So it is important that we should learn about masonry and ensure the safety. Now, some of the students says that, sir, you're talking about 100 years ago, 125 years ago, but what is the current state, that how our masonry structures are performing in the earthquakes? So in the recent earthquake in Nepal, 2015, so again, we have seen similar kind of pictures. The masonry structures have completely collapsed. Okay. Either during the earthquake or during the heavy winds, heavy forces, or because of the deterioration, because of the poor maintenance, durability aspects. So always we are seeing the same story, that poor performance of masonry building. So that is what BIS is trying to now strengthen our masonry codes through NBC, through specialized codes, where the engineers can learn how to make good masonry buildings, uh, either in a zone where the earthquakes are not very prominent, or in the areas where the earthquakes are also very frequent. And also, you should also understand that masonry is still in India and also in the major developing country, it always remains a first priority. So many construction in the villages, in the rural area, in the urban area, they are done using masonry, or in some form we are using masonry. Masonry either as an infill or masonry either as a load bearing member. So now talking about this NBC, where we are talking about the structural design aspect, which is the part 6, in which you have this section 4, which focuses mostly on the masonry. So coming to the scope of this NBC, this part 6, section 4, so it gives us a detailed guidelines, design aspects for unreinforced masonry, load bearing, non-load bearing. Like if we are suppose having the infill walls or the non-load bearing walls, how to design, how to fix the sizes of these walls. So all these things are covered. How we can select the material, selection of a material. Also, it covers the guidelines regarding the earthquake resistant construction of masonry, and also the improvement of masonry with the low strength, low masonry strength. The NBC also covers the design for the reinforced brick slabs and the reinforced brick concrete floors. And also the NBC has also introduced the reinforced masonry, the reinforced load bearing masonry and the non-load bearing masonry walls. So still we do not have a dedicated Indian standard, but the NBC also covers some of the new construction technologies in the masonry. So it is quite important to learn about NBC, this chapter part 6, section 4, so that you can be aware about what are the new technologies we can use for making the masonry construction. Now, this recommendation and the code, the section do not apply for walls which are made using mud mortar. So earlier in many places also you will see in the villages, they use mud mortar. So mud mortar is not covered, or the recommendations are not applicable for mud mortar because mud mortar has a different behavior and they have a very low strength. So the code kind of discourage use of mud mortar for the structural masonry. So, so whenever you start any design or any concept you plan, so you always think of what kind of a material you can use, whatever material are available nearby and which you can use for the construction. So the masonry units nowadays are of so many type of masonry units are available. You can have a clay bricks, the red clay bricks, fly ash bricks, lime bricks, fly ash bricks. So the code gives a good freedom that you can use different type of blocks or bricks. Even you have seen the AAC blocks, autoclave variated cellular concrete blocks can be also used. Concrete blocks, stabilized soil blocks can also be used for the construction of masonry buildings. Now, some of the uh, type of a bricks which has not been allowed, like the previously used masonry units, you cannot use if they are not thoroughly cleaned. And some gypsum partitions can only be used for the non-load bearing. They cannot be used for the load bearing construction. Coming to the mortar, so I hope all of you know about the mortar. So mortar is like a binding material which binds two brick units. So mortar has been divided into different grades, starting from H1 to L2. So H1 mean the higher grade, which is having the higher strength, compressive strength. So H1 mortar says that minimum strength should be 10 MPa and L2 0.5. So depending upon the type of masonry construction, the code provide a guideline that which mortar is good for which type of a masonry construction. And even the code also provide you a tool that for suppose if you want to choose an H1 mortar, you are targeting a strength of 10 MPa, then what should be the proportion? That how much should be the cement, how much should be the lime, how much should be the sand. And this is how the code provide a detailed guideline. So you can get all the information at one place. So that is kind of a beauty of this NBC 2016 uh, section 4 for masonry. So based on the requirement, you can fix the proportion of the mortar for the construction of masonry building. So as I have said, so which mortar you have to use. So like if suppose you are using a mortar for a plaster or a render, then you have to use at least a mortar which is having a grade more than M3. So preferably M2. Without protection, if there is no plaster, no protection is there, then you have to use a mortar of M2. And for load bearing walls, it is set M3 or preferably more than M3. Minimum code allowed L1, but we generally suggest the structural engineer that you should use at least M3 grade mortar for the construction or suggest for the design. For foundation, one can use M3 mortar. So this is all covered in the NBC. I will not go into detail, otherwise it will take a lot of time. So all these things recommendation are given in the code that which type of mortar you can use depending upon the durability aspect, depending upon the exposure condition of a building. So like similar way, we have a concrete grade for a different exposures that what is the minimum grade of a concrete you can use. So similarly here also you can fix the type of a mortar. So coming to the actions, the load, how the loads are transferred and what type of a loads a wall can be subjected to. So majorly the wall registers three type of forces. You can have a vertical compression, as you can see here, we're using a green arrow, these colors, green arrows. So if masonry walls can have a vertical compression, it can also have out of plane shear and bending. Out of plane forces can be there, and out of plane forces can lead to eccentric vertical load, can be due to eccentric vertical load, can be due to the transverse load, and the wall can also have an in plane shear. So in plane shear, out of plane loads are more common, especially during the earthquake, during the wind, and during other kind of a loading. So you have to design your wall for all these three type of forces. For a normal masonry building, the compressions are more prominent, so you have to take care of a compression. But if suppose the loads are eccentric, and if you are designing a building in a seismic zone 5, seismic zone 6, so you have to consider the in-plane forces and the out-of-plane forces because of the earthquake loads and the wind loads also. Now, walls have been primarily classified into two categories. If you will see NBC or IS 1905, it says a bearing wall or a shear wall. Okay, so bearing walls prominently they are designed for a gravity loads, and if the walls are subjected to lateral loads, so we call them as a shear wall, design them like a shear wall. So the code starts first any IS 1905 or NBC 2016. So it starts with some general design consideration that being a engineer, first of all, you have to ensure that the building or a wall should satisfy some of the minimum requirement to ensure the stability of a structure, so that you can have a proper support. You should have uniform loading and the minimum eccentricity. So it is important that you start with the initial planning in such a way that you can ensure the good stability. You can provide some lateral supports so that the slenderness can be limited, and then it can have some good resistance to the horizontal forces. So I will give you some examples that what the code means. So suppose you are having a slab which has to be supported over a wall. So the code says that the slab should at least go at least 90 mm should be supported. And if it is not possible, then you should put a sufficient number of anchors so that the slab or a beam should be supported properly over the wall. So some of the examples, like suppose this is your wall and this is your timber floor or different type of floors. So this is how it can be connected to the masonry walls. Some more examples of a timber, how it can be connected to the masonry walls. So these are some of the basic requirements. One is to ensure to have a proper load transfer, to have a good stability, and to have a good support for various forces. Now, similarly, if suppose you have a quite long wall, so if the length of a wall is quite large, so in that case, the code says that you can have some buttresses, but those buttresses should have these minimum dimensions. So 1/5 of the height of the wall, and the thickness of the buttress should be at least half of the thickness of a wall, or at least 90 mm. Okay, so these are all some of the basic general design consideration which the code suggests has to be followed for the stability, for the good load transfer, and for the good response of a masonry building. And then the code also limits that how much should be the minimum thickness depending upon your use, depending upon the story height. So suppose if your building is, or the story height of a wall is 5 meter, then the minimum thickness should be at least 300 mm. So these are all the recommendation which are given so that one can start the basic design of a masonry wall. So similarly, you can have a crossword also. So many cases, like suppose you're having a classroom or a school building where you can have a multiple cross walls. So in those cases, how the cross wall should be connected. So these are the recommendations which are given by the NBC. So all these things are your basic recommendation. The code also says that you can design currently the code limit that you cannot go more than 8 meter. But if suppose you are going more than 8 meter, then the code says that it has to be designed or the safety has to be ensured by performing the proper structure analysis. So if suppose you have these type of a walls, I type of walls, or where you have a two walls which are meeting the parallel walls. So how to design them? So for a designing, you can consider some effective flange thicknesses or effective flange width. So similar to what you do for a concrete structure also. So the code also provide recommendation that how you can consider the effective overhang or the effective flange width. Then these are some more recommendation. If suppose you have a basement wall, then how much should be the minimum thickness of a basement wall? Basement wall has been kept on a slightly higher side, minimum thickness 300 mm, and it can go up to 400 mm depending upon the type of loads. And then you have the recommendation how you can find out the effective height. So effective height, if depending upon the support condition, you can decide. You can use 0.75 H when it is supported on both the ends. And similarly for a pin end and for the free, this is how the effective height can be calculated. And the code also explains using various pictures, because whatever the previously I have shown here, these are kind of idealistic boundary condition. So suppose you have a walls, something like this, which is having a slab, multi-story building. So how you can find out on for which case you will take H equal to 0.75, for which case you will take H equal to 0.85. So it has been quite beautifully and detailed explanation has been given that how you can decide the effective height of your various walls for the design purpose. Similarly, a detailed example is given for the columns also. And for openings, if you have openings, so then in the case of openings, the piers which are adjacent to the openings, how you can consider their effective height. So all these recommendations are given by the code for finding out the effective height. And similarly, for the effective length also, depending upon the boundary condition, depending upon if you have, suppose openings, if you have the buttresses, so how you can find out the effective length of a wall. So these recommendations are also given by the NBC and or IS 1905. So depending upon the end condition. So these are the various guidelines, various tools which you can use to find out the effective length, which can be used for the design. Similarly, effective thickness, because suppose you have a small buttress or a small, the total pier thickness is TP, then how you can find out the effective thickness of wall? Because considering these kind of a projection in the design is difficult, one has to find out the equivalent thickness or effective thickness. So for that also the code has uh, given the tool. So depending upon this value of TP by TW, so TP is the thickness of a pier and TW is the thickness of a wall. Depending upon these factors, depending upon the value of SP and WP. So SP is the spacing between the two piers and WP is the width of a pier. You can find out how much should be the effective thickness. So like effective thickness can be taken as 2 if TP by TW is more than 3. So these are the various limits on the slenderness ratio. The slenderness ratio, if your number of stories is more than 2, it should not exceed 27. If you're using a lime mortar, because the lime mortar will have a lower strength, bending strength, that is why the slenderness ratio is lower for the use of lime mortar. So now after fixing the basic dimensions, considering all these basic design consideration, then one can move to the design, that how you can design your a wall for a given loads. So if we first of all talk about the compressive loads, so compressive load, then you have to find out the compressive strength. So to find out the compressive strength, the code says that you can do a compression test, which is used using a prism. So you have to make a 5-stack prism, and where you can perform a test and take the design strength as 0.25 times of the average strength which is obtained from the experiment. Or if it is not known, then the code has given a table which can be used. So table looks something like this. So adopted from IS 1905. The same table is given in NBC also. So depending upon the strength of a brick, crushing strength of a brick, and depending upon type of a mortar, one can find out the compressive strength of a masonry. So suppose if you are having a 10 MPa crushing strength of a brick, and if you are using M1 mortar, then you can see the compressive strength of a masonry will be 0.96. Okay. So this is a quite a useful table and quite easy to use by the structural engineers also. So based on the type of brick and based on type of masonry unit and type of mortar, one can find out the compressive strength, the basic compressive strength of a masonry. And so this is the same table which is given by the NBC. So this is, yes, these are the different tests which you can do. So first test is your compressive test to find out the compressive strength of a brick. So this is called the prism compression test. Diagonal compression test, it is not included in the current version of NBC or also in IS 1905, but presently we are revising IS 1905, so it will be included in the new revision. Then the tension bond test, how you can perform, find out the bond strength, the tensile strength of a bond, the shear strength, the flexure strength, parallel and perpendicular bed joint. So all these things, the new test which will be included uh, in a form of an annexure, we are planning to have in IS 1905. So after finding out the basic compressive stress, so you need to apply some reduction factors. Reduction factor, why they are applied? Because if your wall is cylinder, so it is something similar to if you can relate with the concrete. So like you multiply the concrete strength, that characteristic strength by a factor of 0.67, and then further multiply it by divided by 1.5, then you took it at 0.446 in the design. So in a similar way to consider the effect of a various slyness ratio, to consider the effect of eccentricity, you have to find out the reduction factors. So then you will find out the permissible stress in compression for the design purpose. So this stress reduction factor, which is Ks, it will depend upon the slyness ratio. So starting from 6 to 27, so limiting value is 27, and depending upon the eccentricity of a load. So whether the load is applied at concentric at the center of a wall or away from the center of a wall, depending upon this, you can find out the reduction factor. So suppose your slyness value is 10 and the load is applied at 1/6, then you can say the value is 0.85, the value of Ks. So all these things are given in the code, that how you can find out the design or the permissible stress for the design purpose. And further, if the area of a wall is very small, then you can also apply the area reduction factor. You can apply the shape modification factor. So all these things are given in the code to find out the permissible compressive stress. And similarly, the permissible tensile stress. So right now, the current version of NBC and also IS 1905, it simply provides one design value that for M1 grade or better, the strength is 0.07 when the tension is normal to the bed joint, and it can be taken as 0.14 when the tension is perpendicular to the bed joint, parallel to the bed joint. Similarly for M2 grade mortar, so these are the simple recommendations given by the code. And to find out the shear stress, also the code has given some equations which can be used to find out the shear stress. Then some of the requirements are given for the construction. So what should be the good practices one should follow for the construction? I will just skip these. And so the first part of this NBC section 4 on masonry, it covers primarily the design of a unreinforced masonry, URM walls. And then when you go further, then it also provides you the spatial requirement for the earthquakes. So for the earthquake, as you all know that if we make uh, lighter structures, then the earthquake forces will be lower, the inertia forces will be lower. You have to ensure that there should be good continuity of the construction, and then you have to ensure avoids the very large projections, very large suspenders in the various part of a building. Always follow the good building configuration. So these are all covered in the spatial consideration for the earthquake, that you should have regular buildings, rectangular buildings, or a symmetrical plans. If suppose you are having these kind of a shapes, L shapes, so you can, or T shape, you can break them, make it into two blocks. Similarly, the Y shape can be break into the multiple blocks. So this is how you can achieve the various shapes by breaking them into different blocks. Now, one interesting thing which has been adopted from another Indian standard, the NBC has also taken this, that the building for the seismic design or for earthquake design has been divided into various categories. So categories depending upon the seismic zone and depending upon the importance. So suppose if your building is having an importance factor of 1, so for a seismic zone, so the building are divided into different 4 categories: B, C, D, and E. Of course, this will need a revision with the current IS 1893. And so which means that building E, you can assume or you can say that it will be having a more stringent criteria for the design. Okay, a building category E, right? Similarly, if a building importance factor is 1.5, then in seismic zone, you have to design the building considering it as a category E. So now, as you can see here, so there are the requirement given for the ductility. If the buildings are close to each other, then how much should be the separation between the two buildings? So you can see here for category B, it is 10 mm, and whereas for category E, it is 20 mm. So you can see that the these alphabets, so from B, C, D, and E, so E will be corresponding to more stringent criteria, or you can say more strict criteria for the earthquake design. Then how the separation has to be maintained. So these are the various guidelines given. What are the different methods you can use to maintain the separation between the two buildings or to maintain the expansion joint or seismic joints. Foundation, some requirement given for the foundation, RC slabs, foundation, minimum thickness, how much should be minimum thickness. So these are some of the consideration which is primarily from the earthquake point of view, that you have to avoid the roof and floors made of a brick or a tiles, unit supported on this. So these are the various criteria which are given, which you can use for good construction practice. Similarly, for the staircase, we always suggest that it should be separated. It can be separated by providing a gap, and continuity can be provided by using a tread plate. So all these recommendation has been given by the NBC, taken from the Indian standard. Now, as I said, for material requirement also, depending upon the earthquake severity, so depending upon the building category. So you can see here for building category E, you need to have a high strength mortar, H1S2. Okay. Building category B, which will be in zone 2, importance factor 1, then you can even use a lower strength or lower grade of a mortar. So this is how everything has been provided into quite detail and provides a good and easy tool for the designing of a masonry building. If suppose you have openings, so openings can lead to the significant reduction in the strength of a masonry building. So the code also gives a guideline that what should be the size for opening, what should be the appropriate location of a opening from the edges, how much should be the spacing between the openings, the height of a opening. So all these things have been given by the code in a quite easy and a straightforward manner, the which you can use for a different category of a buildings. If the openings are quite large, you can also provide the reinforcement around the opening. So how this reinforcement has to be provided, how much should be the development length of these reinforcement. So all these recommendations are provided so that you can ensure a good performance of from a building during an earthquake. If suppose somebody is strengthening the or planning to strengthen the building, so how these strengthening arrangement has to be done. So this also has been covered by the code. So you can provide the seismic bands, lintel bands, floor band, roof band. You can provide the vertical reinforcement at the corners. So all these recommendations are provided for ensuring the good performance of a building during an earthquake. What should be the reinforcement in the bands? So if your building is in zone in category B, so you can even provide 2 bars of 8 mm diameter. So this is how you can provide the reinforcement in the bands. In some cases, one can also use this special type of a bond where you can create a pocket at the corners, and in that pocket you can provide the reinforcement. And how much should be this reinforcement, what diameter? So all these recommendations has also been given by the code. So this is primarily adopted. We also call them as a quota bond. So some modification of that has been given by the code. So this is for the thin walls. The code also encouraged to use the hollow bricks, which is primarily made using the concrete. Sometimes for clay, but clay hollow bricks are not commonly available in India, but concrete blocks you can use, and which can be used for providing the bands, which and can be used also for providing the reinforcement at the key locations, especially at the junctions or at the corners of a wall. Code also NBC also cover a brief guideline for how you can construct uh, the brick panel floors. However, this construction practice is not used these days. But if suppose you have limited availability of a material like concrete, so in those cases you can also make a reinforced brick floors. So for this, the code also provide guideline that how you can make these prefabricated brick panels or prefabricated brick floors. This is how you can ensure the seismic resistance in these floors. And then coming to the next part of this NBC, so it also provides guidelines that how you can improve the earthquake resistance of low strength masonry. So since as I have shown in the initial pictures, initial slides, that there are many buildings, masonry buildings in India and various places which needs a strengthening. So the code says that for a low strength masonry buildings, you can adopt some of the guidelines which can be used to improve their performance so that they should not collapse during the earthquake. However, these guidelines are not applicable for important building, especially which comes under category D and E. So these are most applicable for buildings which are in B, C category. So stone masonries are very common in rural areas, in the hilly areas. So how you can strengthen these stone masonry buildings? So problem with the stone masonry buildings are they are having a multi-wise, so multi-layers, multiple layers, and it is commonly seen that they separate from in between. So various layers will get separated during the earthquake or during a shaking. So how you can improve their performance? You can do it by providing the bands, or you can do it by providing the through stones at various locations. Regarding the openings, how you can decide the size of opening, location of openings. So again, based on the category B, C, and D, you can decide that how the opening should be located. So all these recommendations are given for that how you can improve the earthquake resistance of a building. So I'm not going to detail, but all these clauses, all these uh, uh, recommendations are given in the section 4 of masonry. Then one interesting thing NBC has also included, which is the design of a reinforced masonry. So somehow still we do not have a code for a reinforced masonry, dedicated Indian standard. But NBC also covers that, which provides some guideline that how you can design the reinforced masonry structures and what should be the minimum requirements, the effective spans, what should be the slenderness ratio, so what should be taken if you are designing a reinforced masonry wall, reinforced masonry column. So all these things are given for the reinforced masonry. In this, however, the code still adopts a working stress method of design because our current IS 1905 or the unreinforced masonry code is on the working stress method, and that is why you can see all these permissible stress in the bars is taken as 140 MPa for HYSD bar, 230 MPa. So these are still have to be updated to a limit state design. So the reinforced masonry code is still reinforced masonry NBC clauses or criteria is still using the working stress method. So what should be the size of reinforcement, maximum diameter, minimum diameter? So all these recommendations you will see in the reinforced masonry section of NBC, this part of NBC. How much should be the development length? So these are quite similar to what we use for the reinforced concrete using a working stress method. How to find out the shear minimum requirement for a shear reinforcement, AV minimum. Then detailing, how you can do a detailing. So you can have reinforced concrete blocks. The concrete blocks are hollow concrete blocks where you can place the reinforcement for a column, reinforcement for a beam, and you can also place the reinforcement along the length of a wall. Yeah, you can also use the Queta bond type of a construction, creating a pocket and then provide the reinforcement. So this is how the reinforcement can be detailed. So various options, various type of a detailing one can use when you are designing it as a reinforced masonry. So these are some of the equations given by the code, and as I said, they are developed based considering the working stress method. All these structural design concept, all they are coming from the working stress criteria. So different performance level which can be expected. So suppose different type of walls. Again, the detailing around the openings, how much reinforcement you have to provide edges to the openings. So these detailing are also quite similar to how we design the reinforced shear walls also. So the reinforced shear wall and reinforced masonry shear walls, they nearly have a similar kind of a design uh, criteria and design requirement. Now this NBC has also included considering the various considering the popularity in the industry, a new type of a bond which we call as a rat trap bond. So rat trap bond, it is nothing but you have to lay the bricks in such a way in a brick will be laid in a edge on the edge, and by when you let the brick in the on the edge, then you will have a pocket, these kind of a pockets which you can see here, and these pockets can be used for providing the reinforcement, and they provide also the better thermal insulation uh, because of these cavities. So these kind of a rat trap bond is also becoming popular, and the code also give a detailed guideline how you can find out the strength of rat trap bond, what type of a testing you can do for these rat trap bond to find out their compressive strength. So these are the various tests which can be done. These are the various bond patterns you can use uh, to have these rat trap bond technology. So very briefly, I've shown that what are the different things which has been covered in the main body of NBC in the masonry section. And then it has also various annexures for finding out uh, the strength for eccentricity of the load, finding out the basic compressive strength using the prism test. So right now only the prism test is included. Then if you have a concentrated load, how you can design the masonry, approximate design for a non-load bearing masonry. Then the code also includes a new type of a construction, which is confined masonry. I will briefly talk about that also. And we have now a dedicated Indian standard on confined masonry, and it will be also included now in the next revision of NBC. And then some methods, iterative method for flexure design and axial load designs to distribute distribution for lateral forces. Masonry walls using rat trap, more detailed designs are given in the annexure H for a rat trap bond. Now, to discuss briefly about this confined masonry, because this is kind of a new construction, and recently we also have an Indian standard on the confined masonry construction. So confined masonry construction is a slightly different type of a construction where you have uh, the masonry wall. So in which, first of all, what we do, we leave the reinforcement coming from the bottom beam or coming from the foundation. Then we construct the masonry wall. And then after the construction of masonry wall, we lay the concrete. So the concrete is poured, and then the advantage of this type of construction is that since we know that the masonry have a very limited tensile capacity and a flexure capacity, so the tensile strength can be provided by these reinforcement, and it will also provide a good deformation and the ductility to the walls. And the bond between the frame, between these RC elements, and between the masonry wall will be also good. And it can be also achieved by providing these shear keys. So this is a kind of a new construction which have a better performance than unreinforced masonry and quite easy to construct also. So, so in this we say that wall first and the tie elements later. So these reinforced concrete element are called as a tie element. So their main purpose or their main role is mostly to carry the tensile forces or tensile stresses. Masonry will be a main load bearing member. Most of the force will be carried by the masonry, whereas the tensile stresses or flexure stresses will be carried by these tie elements. So the concept is why we call them as a confined. So it is something like you have a box of a parcel. You put a string around it to confine the box so that the box should not get open or should not get disintegrated. So the similar concept we have for a confined masonry, where the tie elements, these reinforced concrete element, will confine the wall, will tie the walls, and will avoid the sudden failure of a walls during the earthquake. So this construction is becoming quite popular. It is easy, and the masons which know how to make a masonry wall, they can also learn the construction of confined masonry quite quickly because they do not need a special shuttering. So generally for a column you need a shuttering, for beam you need a proper shuttering. But whereas in for the case of confined masonry wall, you put a shuttering plate only on the two sides or the three sides and you can do a construction. And the beam will be supported over the wall, so for that, you also do not need a very sophisticated shuttering or a formwork. So these are some of the key components. You can have a lintel band, sill band, uh, unreinforced masonry, which will be a load bearing. There will be a tie column. So vertical elements are called as tie column. Horizontal elements are called as tie beam. One can have these kind of a toothing arrangement. Toothing can provide a better bonding, better connectivity between the wall and the RC elements. So, and these confined masonry look similar to the infill frames, reinforced concrete infill frames, but they are totally different. So in the infill frame, we make a frame first, where in confined masonry, we make a wall first, and then these tie columns later. But in the case of a infill frame, we make a infill wall later. So this is how they look different, the RC regular infill RC frame and the confined masonry walls. Their force transfer is also quite different. In the reinforced concrete RC frame, the force transfer is quite complicated because of the separation of a wall from the frame, whereas in the case of a confined masonry, the force transfer is quite straightforward. It is more or less like a reinforced concrete shear walls. So it is a good construction. It provides a better performance during the earthquake. And also the good thing about this construction is that you are designing the masonry wall as a load bearing. So you do not need to have a sophisticated design for a frame. So you do not need to do a frame analysis, transfer the forces and design the frame for the special as a special moment resting frame or as an ordinary moment resting frame. So this is kind of a beauty of a confined masonry where the designs are much easier. So the current NBC covers in an annexure that what type of bricks you can use, what type of a mortar you can use. So since you are designing it as a load bearing, so some requirement is there that the brick strength should be at least 3.5 MPa up to 2 story. For more than 2 story, you should have at least 7 MPa. So all these requirements are given in the code, what type of mortar. You can also see dedicated code now we have for confined masonry, but all these things are also available in the NBC. So grade of a concrete. So since the concrete elements are not load bearing, so you can even use a lower grade of a concrete M15, and the reinforcement FE415 or a 500 different grade for reinforcements are also allowed for use. So these are some guidelines that how much should be the amount of a wall. So in each direction, you should have at least the length of a wall should be more than the 50% of a total length of a building plan. Again, the configuration. So as we have discussed, seen earlier also for unreinforced masonry building. So for a similar also for a confined masonry, the more regular symmetric shape you will have, a better performance you can expect from a building. You should not have a building which are too long. You should not have a building with too many irregular projections or too many offsets. So better to have a regular, a rectangular building configurations. Now, many times we do also mistake. So if you will see in this first figure, you can see that there are a lot of walls in this direction, in the north facing north direction, but the amount of a wall in the other direction are very, very small. Similarly, you can see in this figure B also. So, so these type of a distribution of a wall should be avoided. So you should ensure that you have equal number of a wall area along both the directions, along both the plant directions. So these are not preferred. This is kind of a preferred configuration for a building. The wall should be continuous if you have a multi-story building. So discontinuity should be avoided. Openings should be placed as symmetrically as possible. Such kind of a inadequate location of opening should also be avoided. So all these things are covered by the NBC, by the code which is dedicated on confined masonry. So these are the some of the requirement minimum design dimensions that the tie columns, these vertical elements should be having a spacing of at least not more than 4 meter or should be less than 1.5 times of the height of a wall. At every corner, at every edge, you should have a tie column because the edges and the corners are generally highly stressed where the cracking can start. So wherever you feel that there is can be a possibility of a cracking or damages, you can provide the tie columns at various locations. Then the special consideration for openings also has been given in the confined masonry section. So which says that the opening has to be confined properly. Confined, which means that you should have a confining element above the opening and below the opening. You can see this is one of the picture from a Sikkim earthquake that if you have an opening, then you can have a cracks going all away, all from the starting from a corners of openings. So to avoid such kind of a cracking, you can have confining elements. So confining elements can be provided. You can have a horizontal bands, continuous horizontal band, or you can have a vertical elements also around the opening, continuous vertical elements. So we do a lot of research here at IITs. We do testing that which configuration is better. So I just want to show you some results so that you can appreciate the role of these confining elements. So you have these two walls. So one wall is having no confining element, another wall, one with window opening, door opening, and then same walls which are having the confining elements at the top and bottom of a opening. And these are the bricks which are used for the construction. We have used the English bond. And let me see if this video is playing. Okay, it is not playing. Let's no problem. So one can compare the response in this figure. So you can see here the green curve is for a wall which is not having confining element above opening. Okay. So and this blue color, the dark blue color, the wall which is having the confining element above and below the opening. So you can see there is significant improvement in the performance. Okay. So this wall is with the window opening. So almost the capacity is more than 2 times. So here this wall is with the door opening. So door opening only you have the band or the confining element above the opening. And another significant improvement, it is more than 1.5, 1.6 times. So if you provide these confining element, if you do a proper design, then you can ensure a quite good performance from the walls. So these are the guidelines given by the code that how you can provide the confining elements. So if the openings are very large, if the opening covers more than 25% of your total wall area, total elevation area of a wall, so you should have the horizontal bands. If the openings are smaller, between 10%, 25%, you can have these vertical, and the openings are very small, so they should be less than, then there is no need to provide confining elements. So for a small openings are not a problem. A small opening generally do not interfere or do not have a negative influence on the performance of a walls. Then another new concept which has been introduced in the code. This is not included in the current NBC, but it will be included in the next revision. So where by using the wall density criteria, you can also find out that whether the amount of a walls or the area of a wall in any given directions are sufficient or not. So sufficient for carrying the earthquake forces, sufficient for the transferring the lateral forces. So these are all the criterias or new concept which are coming in the code. So wall density means that if you take total area of a wall in a particular direction and divide it by the total building plan area, so you will get some number, and these numbers, it's so suppose if you want to find out the wall density in the direction in this seismic loading, so you can take all these wall areas, AW, and AW divided by AP, you will get some number multiplied by 100. So you will get a wall densities. And some numbers now has been given in the code, in the guidelines, which you can use and you can check whether my building is having sufficient number of walls for a given seismic zones. So all these recommendations are now given in the code, and very soon you will see a new revision of NBC also and IS 1905. So thank you everyone. I hope I am almost on time as instructed by Abhishek ji. So
Thank
just
you.
try to give you a glimpse. So it is not possible to cover everything because the current MBC, I can say it is very comprehensive. We do not have a dedicated standard, but NBC uh, is kind of a going ahead with the and having various recommendation for the design of masonry. So if any questions are there from the audience,
Sir, thank you, sir. Thank you for your valuable insights on this no uh, particular chapter, because as you know, masonry is not quite popular with amongst students when we compare with concrete and steel. But my question is like, uh, I mean, first of all, I thank you for clearing uh, the difference between this frame structure and confined masonry.
yes.
Earlier I was getting also, I was also getting confused. I mean, what is the difference between these two? But thank
Mm.
you for this. But I just want to know, sir, what is the condition of, I mean, slab? How do you construct slab during masonry construction? I mean, is it
Slab is done like similarly how you do for a reinforced concrete also. So in a similar way, the slab is constructed. So you will have a beams, you will have a, so if the room is small, then you can directly cast the slab over the wall.
okay?
If you have a large room, then you can have a intermediate beams can be there to have a better transfer of forces. But construction wise, everything is same,
Okay.
similar to how we do. See, in the older days, there are different method of slab construction. If you will see the jack arch roof and other type of a
Yes.
roofs, so where we used to have a steel girders, and then over that we will put the stone tiles or different things. Uh, if you're talking about the reinforced brick slab, they are not used nowadays. But the reinforced brick slab construction is also similar to reinforced concrete slabs. It looks kind of a difficult for engineers to visualize. They always think that the reinforced brick slab can fall, the bricks in between can fall down, but it generally do not happen. It will have a good bonding.
Yes. Yes. And sir, one more thing. I mean, since this is the basic, we are basically focusing on this students. And can you suggest, sir? I mean, what are the major areas or topics where they can do research on this particular masonry topic?
So yes, so one thing, see masonry, there are a lot of scope. So first, uh, they can divide or they can think of in two aspects. So first of all is a new construction for masonry and the existing construction. So there are a lot of existing buildings which need to have a significant improvement and strengthening. So they can also see, they can work that what could be the low cost strengthening material, because the existing strengthening material which are available, they are very costly. They cannot be used for the masonry buildings. So what can be the low cost strengthening material which can be used to improve the performance of existing structures? So that is one part. Uh, Low cost meaning that using some natural fibers, using by maybe putting some plasters, a reinforced plaster or reinforced render. So how things can be improved so that we can improve our code. Our code is also uh, uh, do not have very good detailed recommendation on strengthening of masonry. And then next thing is that they can also work on the new constructions. So in a new construction nowadays, new type of blocks are coming. Uh, Masonry blocks, AAC blocks, concrete blocks. So when we are writing this new revision for IS 1905, so the problem which we are facing that we do not have a good data for Indian condition. Now, suppose the bricks which are available in the south, in the north, we do not have actually data. We do not have data for a compressive strength, for a flexure strength. So students can do significant testing, create the database so that we can use it for the development of a code. Whatever we are presently taking idea from some international codes, taking idea from our previous Indian codes. So one important thing is to to generate a database for the masonry properties, compressive strength, shear strength, flexure strength, and then how these new blocks which are coming up can be used for the construction of masonry buildings. And then some more interesting topics also now we are working at IIT Patna. One of my colleague is also working that how we can automate the masonry construction. So can we have a robot which can be used for putting these bricks, placing the bricks, because it is something like a Lego blocks. If you can place these bricks, construct, which is not possible with the concrete, but it can be possible with the masonry. So interesting things are there which can be explored. There are a lot of things which are going on, but the student have to generate interest in masonry first. It is not actually their fault. The fault is that somehow in our curriculum we have removed masonry. We
Yes,
never
sir.
teach a BTech graduate a masonry subject.
Exactly, sir. So, I mean, right now, till now, we have working stress method. We have
Yes.
achieved limit state methods in concrete as well as this steel. But in masonry, will we have this limited state method very soon or?
Yes. Very soon. So I am now convening this group for revision of IS 1905,
Okay, sir.
and we are now removing the working stress method. It will be totally limited state method.
Oh, wonderful, sir. Now, I just want to know about sun, right? Nowadays, I mean, when people are using different masonry blocks with grooves, but no cement or other things, I mean, you can call it drywall construction or something like that.
Yes.
So, how is it? Are we covering in the standard, and how it is different from
See, right
this?
now we are not covering in this standard because what I said that we do not actually have a data. So when we also looked into the new blogs, we also talked to some industry persons. So since because of the absence of these data and absence of having a proper standard on these dry blocks or the dry joint masonry, so that is why in the present revision we are not including. But as soon as we have more information, more database, more test results are available, then we will definitely include these dry wall masonry.
Okay. Thank you so much, sir. I mean, this
Thank
was a
you.
very wonderful session when you talk about masonry chapter. And on behalf of BIS, I extend my sincere thanks to you. And this was very insightful and well structured lecture on part six masonry chapter. So thank
Thank
you
you.
once again,
Thank you so
Dr.
much.
Singhal, for your excellent contribution. Thank you, sir. Namaskar.
Thank you. Namaste.